Moving into chapter number 15, we're going to start talking about waves. Now, when we talk about waves, we can talk about water waves, we can talk about light waves, we can talk about radio waves, things like that, x-rays and so forth. But chapter 15 looking specifically at waves. A wave is just going to be any disturbance that travels through matter or empty space. Now, when we're talking about water, okay, it's moving through a material. But if we're talking about sunlight, between the sun and the earth is absolutely nothing. Some waves can travel through empty space to reach their destination. That matter or material that you sometimes find a wave moving in is going to be called a medium, and it's just the material in which that wave is traveling. So if you have a train on a track and you feel those vibrations, it's traveling through the rail. If we toss a rock into water and that water starts to ripple, that wave is going to be in the water. So it's the material in which that wave is traveling. Now, we've talked about electromagnetic waves. We talked about sunlight, we talked about radio waves, we talked about x-rays, we talked about gamma radiation and things like that. But when we talked about electromagnetic waves, the one thing that we kept saying is they do not need a medium to travel in. So that sunlight, the UV rays, the infrared, the heat, things like that, all of that is going to be able to travel through empty space. Now, there's going to be three types of mechanical waves. Now, a mechanical wave is going to be any one of these waves that has to have a medium or a material to transfer that energy. The three types of mechanical waves are: the first one is going to be a transverse wave. Second one is going to be a longitudinal wave. And the third one is going to be a surface wave, often sometimes called a combination wave also. A transverse wave is a wave that moves the medium at right angles to the direction in which the wave is moving, or to the direction in which the energy is moving. So when you think of a right angle, okay, one is going to be moving up and down while the other one is going to be moving horizontally. Okay, so it moves that medium at right angles to the direction in which that energy is moving. Now, I'm going to go ahead and come back. This is just a online site that kind of shows the three different ones. So I'm going to talk first of all about all three types of waves, and then I'll come back and we'll go to this online demonstration. A longitudinal wave, this is going to be one where the medium moves parallel to the direction in which that energy is moving. So if one's moving horizontally, the other one is also going to be moving horizontally. It'll be moving back and forth to the direction in which that energy is moving. Now, there's going to be a couple different things that we talk about on longitudinal waves. The first one is going to be compressions. When you compress something, you push it close together. So this is the part of a longitudinal wave where the material or the medium is going to be very close to one another. Rarefactions are the part of the medium where it's spread out. Okay, the medium is going to be far apart, or the particles are going to be further apart than in compressions. And the last one's going to be a surface wave. A surface wave is going to be a combination of a transverse wave. So it's going to be going at right angles, but it's also going to be moving parallel. And we have a demonstration of that one also. So let me go ahead and get out of this and we'll go to the online site. Looks like this medium, or it looks like the wave, is traveling all the way from the left to the right. But if you look carefully, okay, there's going to be this little red particle here, and that red particle is going forward and then coming back, going forward and then coming back. So that's what we mean when we say that it is going to be moving parallel or back and forth to the direction in which that energy is moving. And here they actually highlight them and they show you that wave. It doesn't get all the way to the end, but it'll start over. But you can see that that wave appears to be moving from the left to the right, where the particles themselves are just going back and forth. Compressions, close together. Rarefaction, it's this middle part where the particles are going to be further apart. Let's look at a transverse wave. That transverse wave we said was going to be one that was moving at right angles. Wish they kind of highlighted some particles, but if you follow this high point, it looks like that high point is going all the way across the wave. okay, or all the way across the material. But if you look at an individual particle, okay, that particle itself is going up and down vertically, while it looks like that wave is moving horizontally across the page. Okay, so the particles themselves are moving up and down, or like we said, they're moving at right angles to the direction in which the energy is moving. The last one was going to be a surface wave, and I said, well, it has a little bit of characteristics of transverse and longitudinal. It's going at right angles, but it's also going parallel. Well, this is what's going on when we talk about a surface between, say, air particles and liquid particles. We've got air up here, but we've got water down here. But you can see here, it looks pretty much like a transverse wave, where this whole wave is traveling across the screen. But what we want to do is we want to look at the medium. How is the medium acting? So if you follow this, you can see it's kind of going in a clockwise motion. So it's going to go from the top to the bottom. So here's the transverse portion of it, where it goes up and down. But yet we can go over here where it's on the left side, and now it's going to be over here on the right side. So here we have it moving parallel to the direction in which that wave is moving. So we have a little bit of both of them going on. Now, if you look further down here, notice we have a smaller circle. And the reason why we have a smaller circle is, think of this. As we go down or we look at the water, okay, there's going to be all of this pressure or weight above it, so those particles can't move as much because they're going to be more compact. But they still are going in that circular motion, okay?